First, why do mammalian mothers eat the placenta after giving birth? And second, why don't humans eat the placenta after giving birth? So when mammals give birth, you get a lot more than just the newborn. You get the amniotic sac, lots of amniotic fluid, and then down the right we have a cute little newborn kitten still attached to its placenta. Mothers usually deal with this mess by the expedient of simply eating it. They clean the amniotic sac off the newborn, they lick the newborn clean of the amniotic fluid, and when it's delivered, they then eat the placenta. That makes a lot of sense to get rid of that amniotic sac, otherwise the newborn might suffocate. Licking off the amniotic fluid helps the newborn dry very quickly, so you don't have to worry about hypothermia. So that makes a lot of sense. You want to do that. But once you cut that umbilical cord, I think you can see the newborn still attached to the umbilical cord there. Once you cut that, the placenta is completely meaningless. And so why should the mother bother to eat it then? Well, there have been a lot of hypotheses about why this might happen. One, it may replenish resources lost in producing that newborn. However, when people have given mothers an alternative protein source, they usually ignore it. They're not very interested in this alternative food source. They really are focused on eating the placenta because it's a placenta, not because it's food. So that doesn't seem very likely. Probably the most popular explanation for what we will call placentophagy is it removes tissue that might attract predators. However, we don't know of any case where this has actually been tested directly. The placenta has a lot of pharmacological properties. So it may actually prime parent-offspring bonding. There's some pretty good evidence in mammals with biparental care where both the mother and the father take care of the young. It turns out in these cases, the father usually also eats the placenta. So there's good evidence in a couple of rodents that, so maybe it really does prime the parent-offspring bond. Another popular one, especially more recently, is it's been suggested that eating the placenta increases milk production. There's a few suggestive studies, but I don't know of any good controlled studies actually showing that eating the placenta increases milk production. And finally, it's been suggested much more recently that eating the placenta may have an analgesic effect. It may actually ease the pain of childbirth. There's some pretty good evidence that this happens in rodent models, but in a follow-up study using cows, they found no effect. So apparently, maybe rats might get a benefit, but other mammals don't. When you get something like this where one clade is responding in one way and another clade isn't responding to the same thing, maybe we should try a phylogenetic approach to look at these things. Maybe that would help. But it turns out there's never been a comprehensive survey of placentophagy, of eating the placenta in mammals. If you read the literature on placentophagy, the papers all suggest that pretty much all mammals eat it, with just a few exceptions. Those exceptions are us. Although there's been a trend in the natural childbirth movement to get mothers to take the placenta home and eat it. Anthropological studies suggest that no human culture normally eats the placenta. So it has been occurring recently, but it's not really part of our evolutionary past. Cetaceans also don't eat the placenta. All of the Camelidae have been suggested not to eat the placenta, although it's really only been well documented in one species of vicuna. And then pinnipeds are known not to eat the placenta. And that one is actually very well documented in quite a few species. When pinnipeds, when seals and sea lions give birth, they just completely ignore the placenta. And then gulls come in and usually eat it later. Okay, so we've got a few exceptions, but everyone says everybody else eats it. So we want to really test that first of all. How many mammals really eat the placenta most of the time? So we did a big literature review of all the cases we could find describing births, both in the wild and in the zoo. We had about a 50-50 mix. And anytime they described the fate of the placenta, kept track of that, going back into the 1800s. We mapped this out on a mammalian tree. The main tree we used was the Meredith 2011. All of the mammals fit into that tree, goes into the class level. Then we supplemented with a few texts when we went lower than the class. And what we did was we scored placentophagy as being present if more than 50% of mothers observed actually ate the placenta. And we scored it as being absent if fewer than 50% of mothers would eat the placenta. As you can see from this distribution graph on the bottom, the vast majority of species, either all the mothers eat the placenta, that's the 100% over on the right, the blue bar, and on the left, 0%. Most of those mothers, so either mothers ate the placenta or they didn't. There are just a few species where we have sort of a mixture. Some mothers do and some mothers don't. From now on, blue will be species that show placentophagy, and red will be species that don't show placentophagy. So keep track of that. So this is what we got. This is our phylogeny pruned to just the 148 species where we could find data, at least semi-reliable data on what happens to the placenta. We did not get any Xenarthra in this. We had no records about what happens to the placenta in these. For the Afrotheria, we just got the 2 elephants and 1 teneric. But we got pretty good sampling from all the rest of the mammals, especially the primates and the ungulates. Okay, so once again, blue are species that eat the placenta, red are species that don't eat the placenta. When you count them all up, about 27% of the species don't normally eat the placenta. It's not nearly as prevalent as the literature would lead you to believe. It's still almost 3/4, but this is probably, 73% is probably actually an overestimate. If you look a little closer, to begin with, our ancestor reconstruction suggests that eating the placenta is ancestral for at least the placental mammals. It's been lost 14 to 18 times, at least once in all of the major clades, quite a few times in the primates. And once lost, it's been regained 4 to 8 times. Once in the primates, and then the rest, I think, were all in the ungulates. So this is a fairly labile trait. It comes and goes fairly easily, apparently. Okay, so this is the basis for sort of doing some other tests. I don't have time to go through all of these hypotheses. I'm just going to focus really on this one. Eating the placenta might remove tissue that would attract predators. And we're just going to use the ungulates because there were so many gains and losses in that clade. And we're going to use a surrogate for whether or not we're attracting predators. So ungulates have 2 basic neonatal strategies grouped into followers and hiders. Followers, right after birth, the newborn gets up, and within a few hours, it'll follow the mother back to the herd, and they can just leave the placenta behind. And you might even want to leave the placenta behind and get the predator to go over there while you're over here with the rest of the herd. So we don't expect them to eat the placenta. Hiders tend to remain near the birth location for several days, even a few weeks in some species. Mother will leave the newborn, she goes off to feed the newborn, like that little deer over there, will just hide there and depend on crypsis. Hopefully the predator won't see it. And you probably want to get rid of that placenta if it might attract a predator, because it's going to be staying right there. Okay, so we classified our ungulates as hiders and followers, mainly from the Fisher et al. Paper. And here's what we got. So these are our ungulates. On the left, I coded each species as having placentophagy in blue, lacking placentophagy in red. On the right, same species, now they're coded to be hiders in blue, followers in red. And yes, typically hiders do eat the placenta as we predicted. Typically followers don't bother to eat the placenta. Highly significant phylogenetically correlation. So that holds up. In fact, of the 30 species for which we could find data on both characters, only 6 of them don't match as predicted. 5 out of 6 we have, it's a follower that still eats the placenta, even though it doesn't have to. So probably a neutral correlation. No real harm in doing that. The only species where we have a hider that fails to eat the placenta is the giraffe. Don't know why the giraffe doesn't bother to eat it. Okay, so where are we? Close on time. So at this point, placentophagy is not nearly as widespread as literature will lead us to believe. More than a quarter of species don't normally eat the placenta. Bunch of losses, bunch of gains, fairly labile trait. Back to the original two questions. First, why do mammals eat the placenta? I think we've got some pretty good evidence that predator avoidance is important, at least in some clades, at least in the ungulates. Others have suggested that this makes no sense in other clades, like primates. They give birth in the trees, they can just drop the placenta, and they don't have to worry about it anymore, so why do they normally eat the placenta? So maybe we need other explanations. Some of the other hypotheses I suggested probably do hold up. I already mentioned that biparental care in rodents, and there are a few primates with biparental care, and those too, the father also eats the placenta as well as the mother. For lactation and the analgesic hypothesis, it turns out goats and sheep, normally they don't, only about 10% of mothers will bother to even nibble at the placenta. But when they have twins or triplets, that number increases from up to 30 or 40% of the mothers. So it's still less than 50%, but the frequency of feeding on placenta goes up. If you're having more offspring, you might need to prime lactation more. So that may be consistent with the lactation hypothesis. If you're giving birth to more young, it may be creating more pain, and so that also might be consistent with that analgesic hypothesis. Okay, the second question, why don't humans eat the placenta? Turns out humans aren't that unusual, at least for apes. About half the apes do eat the placenta, about half don't. So maybe the real question should be, why has placentophagy been lost so often in the mammals, 14 to 18 times? I think I can get through this. Our current hypothesis, the one we favor, is that this may relate to inter-genomic conflict. So we know in utero, before birth, the placenta mediates resource allocation between the mother and the developing embryo. The mother would prefer to give fewer resources to the embryo than the embryo would like for itself. She'd like to hold some back for future reproduction. This creates the conflict, and from a lot of experimental work, we know that when the balance in conflict currently favors the offspring, you tend to get larger newborns. We take this to our phylogenetic relationship here. I've got maternal mass on the x-axis, neonatal mass on the y, scored by whether or not they have placentophagy, whether they eat the placenta. Species that don't eat the placenta have relatively larger offspring. So, if placentophagy does mediate resource allocation after birth, either through maternal care or lactation, and offspring are currently large, as I showed you in the previous graph, because they're winning the tug of war before birth, then one way the mother might redress this issue is actually to just not eat the placenta. And then she can rebalance after birth resource allocation. And I'll just sum up right now. I'm almost out of time. So why eat the placenta? Predator avoidance seems to be a likely explanation. The other explanations just really need some careful testing. And why is it lost so often? We think it may rebalance parent-offspring conflict from the before and after birth issues. But we really need to confirm that placentophagy mediates postnatal resource allocation.